This video has a box, it's been pushed, so keep in mind it's already been pushed. So when we start this question, this is after the push, okay? So the push has already happened, forget about that. The box is already in motion. The question is asking us for what is this V1? Well, I guess part B is asking, what's that initial velocity? We're also going to find out how much work was done by friction in slowing it down. Okay, so we're not talking about the work that the person does to push it. This is all after the push has happened. Our question starts with the box already in motion. It's going to slide for 12 meters, and then it's going to come to rest. It's brought to rest, so V2 is 0. What we know is there's some friction in here, okay? So mu K 0.75. There's some friction in here that brings this box to rest. And then we're trying to find out how much work that friction does. If we were to draw a free body diagram of this box, we would say, while it's sliding along here, there's a force of gravity pulling it down. There's a normal force kind of keeping it up so it doesn't fall down. As the box slides this way, friction is back this way. Okay, so there's a force of friction slowing this box down. That's what eventually brings the box to rest. And then the question, part A, is how much work does that force of friction do? Okay, so in part A, we're looking for the amount of work done by friction. Remember, the amount of work done by friction is really the negative of the thermal energy. Okay, so in the lesson, we saw thermal energy is FFD. Thermal energy is just positive FFD, but the work done is the negative of that thermal energy. If you kind of think back to our work lesson, our previous lesson, the box is going in this direction. There's the displacement, but the force that's acting on it that we're talking about, the force of friction, is back this way. This angle here, theta, is 180 degrees. So this equation, really, work is FD cos theta. The cosine of 180 degrees is -1. That's what that negative is. Okay, so that thing right there is really the negative of, it's cosine of 180 to give us -1. Okay, so this equation right here, work is the negative of E thermal. Force of friction, a couple reminders, friction is mu Fn. Okay, so we could say that down here, friction mu Fn times d. And up here from our free body diagram, we can see the normal force and the force of gravity are the same. Remember, force of gravity is just mass times 9.8 mg. So the work here, negative mu mg d. Now we can just sub in some numbers. Work is negative 0.75. Mass is 5. G, 9.8. D, 12 meters. And if we work that out, we're going to get negative 441 joules. And for sig digs, I guess we could say negative 4.4 times 10 to the 2 joules. And there's our work. In part B, they're asking for the initial velocity of this thing. So I'm going to go ahead and use our conservation of energy equation. So if I write out the entire conservation of energy equation, work is FAD cos theta. Here 1/2 mv2 squared mgh2 ffd. This thing here, this thermal energy, just remember what we just did over here is find the thermal energy. Remember, thermal energy is the positive version of this work. If I look at this, I've listed what V1 is and V2, but I haven't written down what's H1 and what's H2. I don't know what they are, but I do know that this thing slides horizontally, okay? The box is always at the same level. I'm going to call that level 0, so that the height, I'm going to say this height is height 0. This height is also height 0. It actually wouldn't matter. If I made this height 10, this would be height 10. Whatever's here is also here. Those MGHs are just going to cancel out. Okay, so that guy cancels out, that guy cancels out. In my case, because I'm saying those heights are 0, but even if they weren't both 0, they're both the same number. Okay, so same mass, same G, same H, those two guys cancel out. There's also no applied force acting on this thing. Okay, so this thing is 0, and I'll just say up here, because FA is 0. There's no applied force acting on this box. I know there's an applied force back here when the person pushes on it, but this is after being pushed. So again, forget the person. The box is already in motion. As it slides along, there's gravity, normal force, friction, no applied force. So that one's also 0. The box eventually comes to rest. We're told that. This is also 0. What that means is this thing really simplifies to not very much. We end up with the kinetic energy. As the box starts here, it's got a bunch of kinetic energy. All that kinetic energy gets transferred into this thermal energy. It all becomes heat. Now we can just go ahead and sub our numbers in. This E thermal is, again, the positive version of this. It is just, I'm going to use the unrounded 441. Then we can go ahead and solve, and V1 is 13.28, and for sig digs, we can just say it's approximately 13 meters per second. This equation, just remember, these V's are actually speeds, not velocities. So to make it into a velocity, I just have to choose what direction this is. I'm just going to say forward. You could say east maybe or something. There we go.